Hi everyone. Today we are going to look at the publish subscribe pattern, why it is important, how it works, and the concept of publishers and subscribers. So we will take a very real life example that can help illustrate the publish subscribe pattern in the system design, like a social media platform. Let's imagine Twitter. We will take the example of Twitter. Now, in the context of Twitter, here's how publish subscribe pattern works. Now, imagine you have an account. There are multiple accounts on Twitter, but you have your account. Cool. Now, you are a publisher. Users or accounts on Twitter that can, are considered as publishers. When a user tweets something, they are essentially publishing a message. So each user can have multiple followers. You can have let's say 88 followers, something like that. So the subscribers are the followers of a user that can be thought of subscribers. Now they are interested in receiving updates from the accounts they follow. Suppose these are the 8 people, 1 2 3 4 5 6 7 8. Now these people are going to update the updates from this user. So when a user follow another user, they essentially subscribe to those users tweets. Cool. Now there is a concept known as message brokers. Twitter system itself acts as a message broker in this scenario. It manages the distribution of tweets to the followers of each user. For this person you have this, then this. Similarly, for all the 8 users you have the topics. Now in Twitter, topics are essentially the interest or niches that a user tweets about. For example, a user might tweet about technology, sports, or politics. Now these topics are similar to channels or queues in a more traditional publish subscriber pattern. So here's how a pattern, these things work step by step. So we are going to look at the steps. Cool. So let's suppose we have a user A. Cool. So it tweets something. Now the tweet is considered a message or an event in the publish subscribe pattern. So the Twitter system acts as a message broker. And receives user A tweet. Now Twitter describes which user are following user A. Suppose B is following. Cool. B is following. And it sends the tweets to all of users A. So let's say B is there, C is there, and D. 3 users are following A. Now user B, who follows user A, receives the tweets and views that in its feed. Cool. So user B is acting as a subscriber in this scenario. So user B may also be interested in other topics. So they might follow user C and D. So user B is also interested in other topics. So it might follow C and D. Okay. So user B is acting as a subscriber in this scenario, but user C and D are also, are being followed. So each of these users, they publishes their own tweet, and Twitter B ensures that user B receives these tweets too. So as more users uses Twitter and more followers subscribe to different accounts, the Twitter system continues to manage the distribution of the tweets to the appropriate subscribers. So this was the whole concept using a social media example. Now suppose if I want to take a real typical example, you can think something like this. Let's say there is a publisher, let's say P1, and then you have subscriptions S1. Then you have P2, then you have S2. So these are the channels as we talked about. Let's say this is the channel T1, this is the channel T2. Cool. So PubSub, which is also known as publisher subscribe pattern, as we have talked about it, is a popular messaging model. This consists of publishers and subscribers. So publishers publish messages to special topics. Sometimes these are called channels, the T1 and T2 here. Now, without caring about or even knowing who will read these messages, and subscribe to topics and read messages coming through these topics. Now, publisher subscribe systems often come with very powerful guarantees like at least one-time delivery, persistent storage, ordering of the messages, and replayability of the messages. So these are some of the very important features of PubSub pattern. But obviously, when it comes to operations, you need operations that are independent. So independent operations are very important when it comes to PubSub topic. So let's take an example of how it works. So an operation, let's say for P1, S1 is the subscriber. So an operation that has some same ultimate outcome regardless of how many time it has been performed. Let's say the message has been sent once and the message has been sent twice. Now the subscriber 1 will only receive the message once only. It will receive the message once only. This is the power of idempotent operations. Now it also has a pub/sub messaging system. Typically, since published systems allow some messages to be consumed multiple times, but in this case we need to consider that suppose if a message has not been received, it will keep being sent until it has been received here, but it won't be repeated. Duplicate messages won't be repeated because of the independent operation property of the publish subscribe pattern. Now a typical example of that is Apache Kafka. You have Apache Kafka. Okay, now this is a distributed messaging system created by LinkedIn. So Apache Kafka is a distributed messaging system that has been created by LinkedIn. So it is very useful when we are streaming paradigm is being followed for the particular polling part. We have studied about polling in the previous video, so you guys must be knowing about it. So similarly, this whole concept of publish subscribe pattern work as a cloud pub/sub, cloud publisher subscribe pattern. Now how it is different? So it is a highly scalable pub/sub messaging service created by Google. So this is created by Google. You can go and have a look at it on Google Cloud. So it guarantees at least once delivery of messages and supports rewinding in order to reprocess messages. So yeah, this was the whole concept of publish subscribe pattern. I hope you understood the concept and how it is used in system design. Whenever you are building any chat application or any messaging application, it's a very important design pattern. So in the next video, we are going to talk about maybe MapReduce, why it is important and everything. So yeah, thank you and have a nice day.